All right, so let's look at the gradient of a line segment. So the gradient, or the slope of a line, measures how steep it is and the direction it goes in. The symbol we use for gradient is an M. You might remember that from last year. And last year we defined gradient as rise over run. So we said it's how much we went up and down. So that would be your Y movement. And how many we ran left or right. So let's look at the blue line here. And if we look at the blue line, let's just see how far are we running up and down. So up and down will be our Y. So the gradient of AB. All right, so we've gone from -2, the Y value -2, to the Y value 4, which means we've gone up 2 to get to 0, then another 4, which gives me a total of 6. So that is a rise, gone from -2 to 4, so it's a rise of 6. So it's up, so it's a positive 6. Okay, and then how many have we run forward? Well, let's look here. This is my run forward. So I started at -3 and I'm ending at 1 on my x's. So that's going to be from -3 to 1 would be 3 to 0, and then another 1, which gives me a total of positive 4. Okay, so then I could divide 2 into the top and the bottom, which gives me a gradient of positive 3 over 2. Okay, so this is a positive gradient. And if you can look at the blue line goes up from left to right. So when you're looking from left to right, that's going that way, left to right. Okay, the B is lower than the A, so your line has gone up from left to right. So a positive gradient goes up from left to right. Okay, let's quickly look at the little green line there. All right, so I need to look at my rise, that's this one here, and then my run, which is this one here. Okay, so the gradient of CD. Okay, what have I done here? Well, looking from left to right, my y's have gone from -1 to -5. So they've gone down 4. Okay, this is down 4, so we write -4 for the rise. It's a negative rise. And my run, well, I've gone from 2 to 4. So that's going to be a positive 2. You've gone 2 forward. So that gives me a -2 gradient. Okay, so this is a negative gradient. And if you look at the green line, it goes down from left to right. So C is higher than D. It's going down from left to right. So this goes down from left to right. Okay. Now, instead of using rise over run this year, we change this into a formula. And to get the rise, we just take the 2 y values and we subtract them. Because when we subtract the 2 y values, that will give me my rise. And to get my run, we subtract the 2 x values because that will give me my run. So we change this into a formula this year. And we change it into this formula. So if we wanted the gradient of AB, we would go the y at A minus the y at B. That would give me my rise. And the run would be x at A minus x at B. So we're going to use this formula instead of counting the gradient this year. And just remember that if you pick up A first at the top, then you must pick up the coordinate of A first at the bottom. You can't mix those round. And you also have to always remember that you have to have your y's at the top and your x's at the bottom, so that you get your change in y at the top and your change in x at the bottom. All right, so that's our gradient formula. So now I've got a whole lot of lines here, and we're just going to look at finding the gradients of these lines. So let's start with the two blue lines. Okay, so we're going to try find the gradient of PQ, and we're going to use our formula instead of counting. We could count it, but we're not going to. We're going to use the y at P minus the y at Q over the x at P minus the x at Q. All right, so P is 0, 3. So the y at P will be a 3. And the y at Q would be a 0. The x at P is a 0. And the x at Q is a negative 2. And because we're subtracting a negative, we write it in a bracket. So we've got 3 minus 0 over 0 plus 2, which means it gives me a gradient of positive 3 over 2. Okay, and that is a positive gradient because my line is going up from left to right. Okay, now I'm going to look at the other blue line. So what is the gradient of DC or CD? Okay, it doesn't matter which order you pick up your letters as long as you keep the same ones first and then the others last. Okay, so we're going to have the y at C. I just always follow what I've written here. Minus the y at D over the x at C minus the x at D. Okay, so the y at C is a 3. And the y at D is a 9. The x at C is a 4. And the x at D is an 8. Okay, so I've got 3 minus 9 is a negative 6. 4 minus 8 is a negative 4. A negative over a negative gives me a positive, and I can divide 2 into the top and 2 into the bottom. So again, I get positive 3 over 2. So these two lines have got the same gradient, these two blue lines. And if you look at these two blue lines, I don't know if you can see, but these lines are actually parallel to each other. Okay, so parallel lines have equal gradients. They've got exactly the same gradients because they have to have the same slope. Okay, parallel lines have got equal gradients. So if I want to show that two lines are parallel, I'm going to show that they've got the same gradient. Okay, let's look at the orange line now. So we're looking for the gradient of EF. So it's the y at E minus the y at F over the x at E minus the x at F. Okay, so the y at E is, the y at E is a 3. The y at F is a negative 1. And again, please be careful when you're subtracting. Put it in a bracket like that. Otherwise, your signs are going to be wrong. Okay, x at E is a 2. X at F is also 2. So that gives me 3 plus 1, which is 4, over 0. Do you remember that anything over 0 is undefined? All right, so why does this have an undefined gradient? Well, it has an undefined gradient because the change in x, the x's don't change. Your change in x is 0, and that is a vertical line. So a vertical line has an undefined gradient. Okay, and how do I know that a line is vertical? A line is vertical if your x values are the same. So a vertical line has the same x values. So when you're looking at x values, if they're the same, it has to be a vertical line. Okay, all right, so what about the red line? Now that one looks like a horizontal line. Okay, it's going across from left to right. So let's just double check. Let's find the gradient of jk. So it's going to be the y at j minus the y at k over the x at j minus the x at k. Okay, the y at j is a 5. The y at k is a 5. The x at j is a -2. The x at k is a +3. So that's 0 over -5, which is 0. So a horizontal line has a 0 gradient. Okay, and how do we know a line is horizontal? A horizontal line has the same, let's look here, it's got the same y values. Okay, so when you're looking at something, check to see whether the y values are the same. Okay, so now I haven't done the green line yet, which we're going to do. Just going to do over the page quickly. So we've got A is 3, 8, and B is 9, 4. Okay, so the gradient of AB is equal to the y at A minus the y at B over the x at A minus the x at B. Okay, so the y at A is an 8, y at B is a 4, x at A is 3, x at B is 9, 4 over -6, divide. Okay, so positive over negative gives me a negative, and then we get 2 over 3. And if we go back and look at this one, it has got a negative gradient. It is going down from left to right. Okay, now if we look at CD and AB, can you see that they look like they could be at 90 degrees to each other? And we can check that by checking our two gradients. Okay, so these two lines are actually perpendicular. And let's look at the two gradients. So the gradient of CD was 3 over 2. Look at CD. The gradient of CD is 3 over 2. And AB, the gradient of AB was -2 over 3. When you look at these two gradients, can you see that they're the inverse, the reciprocals of each other? This is 3 over 2, this is 2 over 3, but they also have the opposite signs. So if two lines are perpendicular, the product of the gradients is -1. Okay, so if we look at 3 over 2 times -2 over 3, can you see that gives me -6 over +6, which is -1. So what we can say is, if you check two lines, so if the gradient of AB times the gradient of CD is equal to -1, then AB is perpendicular to CD. Okay, so that's what we know about perpendicular lines. Okay, so also what we could do is if I said to you, this line here, say MN, has a gradient of 1/2, the line perpendicular to that one would have a gradient of, well, we'd have to flip it upside down and change its sign. So that would have a gradient of -2. So we invert and change sign. For a perpendicular line. Alright, so finally we're just going to look at where the lines are parallel. Remember parallel? We said they had equal gradients. Perpendicular, when we multiply the two gradients together, you have to get -1 or neither. Well then, they're not equal and they're not going to give you a product of -1. So we're going to quickly just do the first one. So the gradient of AB is the y at A minus the y at B over the x at A minus the x at B. And if we look at that, it's going to be -4 minus 4 over -8 minus 2. Okay, so the gradient would be -8 over -10. Dividing 2 into the top and bottom and dividing your signs, you're going to get 4 over 5. Okay, what about the gradient of CD? Well, the y at A minus the y at C, the y at C minus the y at D over the x at C minus the x at D, and we're going to end up with 0 minus 20 over -4 minus 20. Again, be careful. The x at D is a -20. So that's going to give you -20. And -4 plus 20 is going to give you +16. Divide 4 into the top and 4 into the bottom. It's going to give you a -5 over 4. So what do I know about these two gradients? They're not equal to each other, but can you see that they invert? We flip them upside down and we've changed the sign. So we're going to go, therefore, the gradient of AB times the gradient of CD is going to be 4 over 5 times -5 over 4, -20 over +20, which is -1. Therefore, AB is perpendicular to CD. Okay, so because the product's -1, and you need to show that it's like a reason for that they're perpendicular. Okay. Remember, this upside down T sign means that they are perpendicular. Okay, so let's try the next one. A is 5, 6. B is 4, 2. C is 8, 24. And D is 4, 8. Okay, so the gradient of AB is the y at A minus the y at B over the x at A minus the x at B. Okay, so it's going to be 6 minus 2 over 5 minus 4, 3 over 1, which is 3. Okay, the gradient of CD, there's my formula. The y at C is 24, y at D is 8, x at C is 8, x at D is 4. that's going to be 16 over 4, which is 4. And I've just realized here that I can't subtract. Sorry, what's 6 minus 2? It's not 3. Let me try that again. 6 minus 2 is 4. 5 minus 4 is 1. And that's going to be 4 as well. I apologize. So can you see that the gradient of AB is equal to the gradient of CD? Therefore, the lines are parallel because they've got equal gradients. All right, and then this video has gone on for a bit long, so what I'm going to do is I'm going to just tell you that with the last example, the gradient of AB here and the gradient of CD and the last one, number 3, you get numbers that are not equal to each other, the gradients, and the product is not equal to -1. So then we would say, well, then they are neither parallel or perpendicular. All right, so that's just a little description of gradient and what you can do with it, proving lines parallel, perpendicular, and I'm going to give you some examples to try now.